Hi, and welcome to the Global Azure Bootcamp 2015. My name is Rainer Stropik. I'm an Azure MVP, Microsoft Regional Director, and I'm part of the organization team that is responsible for the local event, local bootcamp event in Austria, Europe. In the next 50 to 60 minutes, I would like to introduce you to Microsoft Azure App Services Web Apps, or how it was formerly called, Azure Websites. Azure Websites is really a great platform as a service offering. We use it a lot in the consulting work, in the training work that we do, but also in our professional software development for our own software as a service solutions. How will I structure this recording here? By the way, as you might see here on this website, the Global Azure Bootcamp has not yet started. It is still a few hours to go. But I thought I should pre-record this session because tomorrow at the bootcamp I will do the session in German and the recording should be in English. So this is the reason why I pre-record. Okay, so how will I structure this 60 minutes, this upcoming 60 minutes? We will spend the entire time in Visual Studio and Azure related tools. I will not show you any kind of slides or things like that. We will really go down to the code, make a code-only session, and watch how Azure Web Apps is working based on 3 different scenarios. We will start with a very basic scenario, static websites, static content, and I'll show you how you can deploy to Azure Web Apps using very simple FTP option. Essentially, you would not even need Visual Studio for that. I will not use Visual Studio. You will see how you can just interact with Azure websites with an editor and an FTP tool. The next sample will go one step further and contain some server-side logic. We will use JavaScript on the server, so we are going to use Node.js. And we will develop a very, very small application. This is not a Node.js session, so if you are not familiar with Node.js, that's absolutely no problem. We will focus on the web app part. We'll take Node.js, and in this case, we're not going to use FTP, but we are going to use Git integration. We are going to integrate a local Git repository with a repository in Microsoft Azure in the web app, and push our changes via Git into the cloud. The third sample is for the C# and ASP.NET developers in the room. So we are going to use Visual Studio to write very, very simple web application. Again, this is not an ASP.NET or C# session. We are going to focus on the web app part. And we are going to take an ASP.NET application, develop it locally, use Visual Studio to deploy it to Azure Web Apps, and if we have the time, we are also going to integrate our Azure Web App with Visual Studio Online to set up a continuous integration pipeline. Okay, this is our program for the next 60 minutes. We are ready to start with the first example, basic workflow with static website and FTP. Before we can get going, we need to create our first web app. Let's do that. I have opened the new portal here. This is the new preview portal for Microsoft Azure. Many of you might already know it either from other sessions at this Global Azure Bootcamp or from your own experiments with Azure. This portal is currently in preview. I will try to do as many things as possible in this preview portal. This is, if you're new to Azure, this is how the current production portal looks like. And of course, you can do all the things that I'm going to show you in the next few minutes in the current production portal too. But let's stick with the preview one. It looks a bit nicer. It is the more modern web application for dealing with Azure. So let's create our first web app. For that, we hit New, select Web and Mobile, and choose Web App. Now we have to specify a few settings. First one is the URI. Let's call it GAB for Global Azure Bootcamp, AT for Austria 2015, and the first sample is the static web sample. Let's see if the URI is already taken. No, it's not. So we can reach our application at GABAT2015 staticweb.azurewebsites.net. Next, we have to specify the app service plan. So what is the app service plan all about? You see, the app service plan, you can imagine the app service plan like your web farm. You're configuring a web farm, and this is called a service plan. And after that, you can deploy multiple web apps into the service plan, meaning the web farm. All the web apps in a single service plan share the same underlying infrastructure. So we are also only paying for the service plan and not per web app. So what could you do with that? Imagine you have to run multiple versions of your application at the same time. Of course, you don't want to pay for each version. For that, you could create a service plan, deploy all the different versions into a single service plan. You only pay once, and all your versions, they are separated, but they share the same underlying infrastructure. Of course, you can decide to create multiple service plans. If you have, for instance, a very large customer, you can give them their own farm. You can use the smaller ones. You can group them together on a separate service plan. It really depends on your needs. So for us, we are going to create a new service plan here. Let's call it GABAT service plan. Let's see if this name is already taken. No, it's not. We get the green check. Next, we have to specify the pricing tier for the app service plan. The pricing tier specifies the available features and, of course, the costs. If we turn on all the different pricing tiers, you see there are many different options. It starts with the free option, as you can see here. Free means really entirely free. Free forever, not only for 30 days. However, the free pricing tier is really limited in terms of functionality and the available underlying infrastructure. Means you only have limited CPU time, you have limited memory, and so on. So this is really good for experimenting, for learning Azure. If you are a student, for instance, then you can use the free tier to learn about Azure. A very cost-efficient way of running a website is the shared plan. Shared means that you share the infrastructure with other Azure customers. So you are not alone on your server or your server farm. Well, on the other hand, you already get some advanced features like custom domains, for instance. So a shared plan is a good idea for small websites. Think of your hobby soccer club website. This is something that you could run in shared mode, very cost efficient. In this case, only €7.20 per month. If you're really serious about Azure and you're doing serious business, you will end up using the higher price plans. Up here you have the basic plan, the standard plan, the premium plan. It is out of scope of this presentation to go into all the details what these different pricing plans are capable of. If you want to know the details, I encourage you to take a look at the azure.microsoft.com website. Here you find a tab which is called Pricing. And if you scroll down a bit, you'll see the App Services area here. And inside of the App Services area, we can scroll down a bit, and here you already see the different services with their capabilities in a nice table compared one by each other, and you can see the different prices of the different pricing tiers. So if you want to know the details, please check azure.microsoft.com. For us, the standard price tier here is perfectly fine. So I'm going to select this one. Okay, fine. I'm here in Austria. Austria is in Europe, and so I'm going to select North Europe as our target data center. So these settings, they look good. I think we can start creating our web app and our service plan. We hit Create. Now, Azure will create this web app and the service plan in the background. It will only take few minutes, maybe even seconds, we'll see. In the meantime, while Azure is creating our web app, we can prepare some static content that we could put out into the cloud. So for that, let's go to my PC, go to C drive, and let's create a folder here where we can gather all the samples. Let's call it samples. And here we create a folder. Let's call it static web. And inside the static web folder, let's create a very simple text document, default.html. Yes, I am sure I want to change the name. Let's use a simple text editor to enter body. Very, very simple content. H1, hello from Global Azure Bootcamp. Yeah, that's enough for our example. We have a default.html, and this default.html is the static website content that we would like to deploy to our newly created Azure Web App. So let's go back into the portal and take a look what's happening here. Well, it seems that Azure has created something, but currently the screen is just blue. Okay, let's refresh it. Did I mention that this is the preview portal? Well, that can happen in a preview, right? But we have a production portal. If something turns out to not working as expected, then we can move from the preview to the production one. But I'll give it a second try. And I think it looks good. Refresh helped, because here you see our Global Azure Bootcamp Austria 2015 static web app. Before we start to deploy our application, I want to give you a short walkthrough through the different options you have inside of the Azure portal if you configure your web apps. I will not be able to demo all the different options and possibilities of the Azure Web Apps here in this 60 minutes, so it would be maybe nice if we take a look around and see what's going on. Preview is currently a bit slow, so you know what? We go to the production portal and take a look here. Let's refresh it so we see our newly created web app. Let's see if the portal, yes, the portal has recovered. Let's stick with the preview one. Give it a last chance. Maybe it's working now. So let's go into the settings here. And let's look at the different options that we have here. By the way, it's here. Here's the preview one. Here's the configure tab. Here we can configure our website. That's the same view in the current production portal as we have here in the preview portal. Here you have it in the preview portal. Properties are some general properties for your website. The first one, which might be interesting to you, is application settings. The important idea of a platform as a service offering like Azure Web Apps is that you don't have to care for things like operating system, installing and setting up the web server, installing and maintaining .NET or Java or PHP runtime, install some settings or executing some configuration tools to enable remote debugging. You don't have to do that yourself. The underlying platform, the Azure Web Apps platform, is caring for that instead of you. You can really focus on implementing your own application. So here you see it in the current production portal, how the configuration is done. You need a different .NET framework version? Well, here you can just click it, hit save, and it's done. I want to demo it with another thing. Imagine you want to run 64-bit servers instead of 32-bit servers. Just click on 64-bit, hit save, and that's it. That's the power and beauty of a platform as a service offering. We don't have to care for setting up a new machine and things like that. It was a question of a few seconds and we switched from 32 to 64 bits. You can turn on off WebSockets and things like that. We will discuss Visual Studio Online later on. You can upload certificates, you can manage your custom domain names. You can, for instance, set up logging. You see, we will use that in a few more minutes. You can configure whether you want detailed error message and so on and so on. In the sake of time, I will not walk you through all the different configuration options, but I think you get the idea. Platform as a service means not configuring your virtual machines yourself, but having a nice and beautiful UI where you just configure it and the underlying platform is caring for the rest. Well, you might ask yourself, where's the gotcha? The gotcha is you have exactly these options. You need an entirely different .NET Framework version? Well, then you can't use Azure Web Apps. You're really limited to these standardized functionalities. If you can't deal with them, you have the best service in the world. If you need something more customized, well, then you have to switch to other platform as a service offerings like cloud services, or you have to even go back to virtual machines and configure the system yourself. That's really up to you. In my personal opinion, try to be able to work with a thing like Azure Web Apps, because this really gives you the cost benefit of the Azure platform. Okay, now we have seen what we can configure in this area, and in the new portal you even get more options. You can, for instance, turn on authentication via Azure Active Directory. You can do things like traffic routing to for instance, deploy a new version and put a certain percentage of the traffic to the new version and things like that. We have only 60 minutes and I want to handle the basics, so I will not go into these details, but I encourage you to read the documentation and check azure.microsoft.com. There you find examples and walkthroughs for all of these configurations. For us, we now want to deploy our first content. So let's go to the properties section here, or in the current production portal. You have it here on the dashboard. You see here on the right hand side you have the different options, and this is how it looks in the new portal. In our case, I want to demo how to use FTP in my first example. So what I'll do, I copy the FTP hostname into the clipboard and I use an FTP tool, in this case FileZilla, paste in the name of the server. Then the system asks me for a user. You can see the user account here. Let's copy this one into the clipboard too. If I manage to mark it, well, let's use this one. Go back to FileZilla. And of course I need a password. Hit connect. And you see, I'm up and running. I can look at the site, I can look at the root directory, and what we have here is a hosting start.html file. This was created when we first created the Azure Web App. We can get rid of it, we don't need it currently. We want to deploy a different file. We created the file in the sample directory, and there we have our static web, and this is the default.html file that we created a second ago. So how can we deploy it? Well, we take the default.html file, we drag and drop it to the right hand side, we go back to the portal, and that's it. We run the website, and here it is. Hello from Global Azure Bootcamp. It's really as simple as this to deploy a static website, some static content, to manipulate your config files and things like that via FTP. That works great, and it's a very simple option for maybe smaller projects. That's absolutely fine. Well, you might ask yourself, what happens if I scale? So is this content persistent? And the answer is yes, it is. The content is technically stored in Azure Blob Storage, so in a highly available storage engine. If we go, for instance, here to scale and we decide to change our web server to a web farm, we can just say, you know what, we don't need to schedule, we don't need to watch the CPU. I just want to change the number of instances here to, for instance, 3 and hit save. That's all we have to do to turn our single server into an entire web farm consisting of 3 servers with a load balancer and things like that. So after only few seconds, we have our web farm consisting of 3 instances. And as I mentioned before, you could also schedule these scaling operations, or you could monitor the CPU utilization and change the number of instances based on the CPU utilization. In our simple example, we imagine that now we have less users on the website, for instance during night, so we can scale down again to save costs. Hit save. And that's it. Now we got back from our web farm to a single server. Please note that this scaling is done per service plan and not per web app. So it influences all the web apps that are inside of the service plan. So this was our first very basic and simple example where we took static web content and used FTP to deploy it to our Azure Web App. I think we can move on and go to our second example where we really want to execute some logic in the cloud in an Azure Web App. For that, we're going to create a new web app, and this time I'm not going to show it to you in the new portal, but just to make sure you see all the different aspects of Azure Web Apps, I'm going to use the current production portal. You see, I hit plus, I hit quick create, and the first one was called GAB for Global Azure Bootcamp AT for Austria 2015, and the first one was called static web, and this time we call it Node.js. Server-side logic. You see here we have the app service plan that we created in the course of the first sample. This service plan is now reused, so we are deploying a second web app into the existing service plan, so we don't spend more money just because we need two applications. It's perfectly fine for us that these 2 applications are sharing the same underlying infrastructure. Let's hit create. Okay, so Azure will create the web app for us, and in the meantime, while the web app is created, it's already done. It only took a few seconds, but now we have to create our content. For that, we go into Visual Studio. This Visual Studio 2013 here has the Node tools for Visual Studio installed. Therefore, we can say File, New Project, go down to Other Languages, select JavaScript, Node.js, and for instance we can take basic Node.js Express 4 application. Let's put it in our C samples directory again and call it Node sample. Hit OK. Now the Node tools for Visual Studio are scaffolding a very basic application. It just displays a greeting message. And for those of you who are not perfectly familiar with Node.js, I'm going to walk you through the generated code in a second. It's not a lot of code. Everything starts with this startup script here. It's called dub. And you see it has some require statement. This is loading some modules. It's setting some ports here. Let's change this port to 1337. That looks good. And the first important thing that I have to do is I have to move this dub script to the root directory here and rename it to server.js, because Azure is going to look for a script, for instance, that's called server.js as its startup script. That's okay, server.js, and yeah, let's take a look at the rest of the code. This server.js loads the app.js, the app module, and this module is using different Node.js modules. You see the express module is used, body parser is used, and things like that. And these modules are referenced in the package.json file. Here you see the dependencies. For those of you who don't know Node, but who are C# and ASP.NET developers, you can think of these dependencies just like your NuGet dependencies in your ASP.NET file. And finally, here we have our views directory, and here we have an index.jade file. This is a Jade content, and it's translated to HTML during runtime, and this is the server-side logic that we want to execute in our Node.js application. Okay, so let's build this one. Okay, build succeeded. It built without any errors, but there is an important mistake here. You see, we require ... so one directory up, the app directory. This is because previously we had the ... script in the bin directory and the app.js one directory above. But we moved the ... content one directory up, so now this is wrong, but I'm not going to correct that. I want to deploy the application just like that, and you're going to see how we are doing some basic troubleshooting inside of Azure. I'm going to show you how to look at the logs, how to look up the error, and how to correct it again. Okay? So our first deployment will fail, and then we have to do some bug fixing. Okay, this time we're not going to use FileZilla, so I can close it. This time I want to show you in a second scenario how to use Git to deploy your application with server-side code. For that, I go back into my portal and open the Azure Web App here, and we can choose Setup Deployment from Source Control. In the new portal, okay, it's again blue. I think I have to restart the portal, my browser here, so it will stay with the production one. I'm going to set up a deployment, and here you see local Git repository. I will set up a local Git repository and push my changes out into my web app using Git. Let's select the local Git repository. Setting up a possible connection for my local Git repository only takes few moments. Here we have it. And then we get a Git URI, and we copy that into our clipboard. Now here we are in which directory? Let's check that one. Properties. We are in the C samples node sample directory, so we can start. Let's start a new shell here. Okay, go into our project directory, samples. Oops. Okay, here we have our directory, as you can see that, and now we set up the local Git repository. I'm using only the command line Git tools here to show you that you can, of course, use Visual Studio, but you don't need to. If you want to do the same on Linux, on your Mac OS device, absolutely no problem. Git is available. Use your editor of choice, Sublime Text, or whatever you want to use. Microsoft Azure Web Apps is perfectly fine with that. So let's use the shell here. Let's do a git init first. Now we have a Git repository. Okay, we have a Git repository, but we have a very special directory here. It's called node_modules, and this directory contains all the node modules that are installed from this package.json file. It's like the packages directory for NuGet. We don't want to publish these modules. Azure will automatically understand package.json during deployment and fetch the node modules in the cloud. That's very, very handy, but to suppress the deployment of node_modules, we are going to create a special file that you probably know, the gitignore file, node modules, and let's see if we have anything other. Yeah, we don't need the bin directory, we don't need the obj directory, and we don't need NJS project files. Okay, let's save this one. It's in the C samples node sample and call it gitignore.gitignore file. Let's check if everything is fine. We do a git status, and you see node modules is not inside the list of files that will be included in our git add. So let's say git add dot node modules will not be included. Do a commit. Everything is locally up to now. Let's call it initial commit. Okay. And now the question is, how can we get our code out into the cloud? Well, for that, we need this git URI. Because this git URI can act as a remote. So we say git remote add. Let's call it Azure. This is the name of our remote. And then we need to specify the URL. Here it is. And now we can simply push our files into the Azure Web App using git. Git push name of the remote, Azure, and master, because we don't have any branches or something like this. Very simple scenario. Of course, it is password protected, so I get asked for the password. I will enter the password. And now the deployment mechanism of Azure kicks in. So what's happening here, it's copying the files, and then it looks at the files, it detects the startup script, it's called server.js. You see the portal is automatically refreshing, it's telling us that it's currently deploying a new version of the application. The deployment mechanism, which is by the way called kudu, the kudu has detected the package JSON file and is now executing the npm install. It's just like a NuGet package restore for the Node.js application. And with that, we're done. You see, we have an active deployment. And if I go to the dashboard and select the, where is my URI? Where is my URI? Here's the URI. Open this one, for instance, in a new window. Let's see what happens. HTTP 500. This is exactly the error that I told you before. It doesn't work because we have a wrong path in our application. But how can we find out? How can we do some troubleshooting here? For that, I'm going to go either in the new portal. Here we can set up log streaming, or we could also do that in the old portal. If we go to configure, we could turn on diagnostics. We can say, hey, give me application logging and give me verbose application logging. Hit save. This reconfigures our web app, and the new portal has a very nice functionality here. I'm very sorry, please understand that I close my browser here. Something goes wrong here, I don't know why. I'm reopening the browser and I'm hoping that new portal will work again then. Logging in again. I'm sorry for that. Okay, let's go into browse. And we should have web app here. Let's reopen the web app for Node.js. Here is our Node.js application. Scroll to the right. Then we can go to all settings. And in the application section, application settings section here, just to show you how this looks like in the new portal. We can set the configuration settings here. And if I scroll down a bit, oh sorry, you see, here are the settings in the new portal. You see, application logging on, and we set the level to verbose. So it really depends on which portal you like most. My recommendation would be give it a chance, give the new portal a chance, try it, and if you hit some walls, if something doesn't work, go back to the production portal. And in our case, I want to use a very nice feature here of the new portal. I can use streaming logs. Once you have set up and activated the diagnostics log, you can hook up your browser window to the web server logs. And with that, I can open the URI. Here, we have the HTTP 500, then I go back to the streaming log, and hey, you see, /app, the system cannot find this module. So I can say, oh, I know what happened. Let's go back to Visual Studio and remove one dot. Save it. Go back here, add the changes, commit the changes locally, bug fix. Push the change, git push Azure master. Of course, I could ask for the password again. Now it pushes my change into the Azure Web App. And if you closely monitor what Kudu is doing, you will see that it will not run npm install again. It was quite fast. We can go back to our portal. Here, hit Ctrl F5 to refresh this website, and if we are lucky, we are going to see a Hello World message. And this time, Node.js should work fine. Here we are, Express, welcome to Express. We can go to the streaming logs, and you see no error message anymore. So the sample succeeded. Finally, after some hiccups with the new portal, what did we do? We used Visual Studio and Node.js tools to create a Node.js application with server-side logic. There was a bug in our solution, and we didn't remove the bug because I wanted to show you some troubleshooting. Then we pushed our application into the cloud using Git, and we also corrected the application, and you have seen how you can use log streaming to do some basic troubleshooting. This was our second example. I think we can go on to the third one with C# and ASP.NET. Before we start implementing our next sample in Visual Studio, we have to, of course, create another Azure Web App. We hit New, select Web and Mobile. You see there is also a shortcut here, so the portal remembers your recent choices, and I can select the web app from down here directly. And what was the name of the previous sessions? I think it was GAB for Global Azure Website AT 2015, and this time let's call it ASP.NET. Let's see if this is taken. No, it is not taken. Of course, we select our existing app service plan, we stick to North Europe and hit create. So now we are creating our third web app, and this third web app should be created in Visual Studio. So let's go to Visual Studio and close the Node.js project and create a new project. This should really not become an ASP.NET session. I don't want to do any fancy big stuff here. We are going to create an ASP.NET web application. Let's call it ASP.NET sample, put it in the samples directory again. and we really take a very basic one. We take the empty one and fill it with just a hello world message. You have to imagine that in real world we would now write some fancy web application using the ASP.NET MVC framework, for instance. And of course you can also create some web APIs using ASP.NET Web API. So let's add here one file, new folder. Let's call it startup. C# file here. Let's call it startup. And to make it an ASP.NET OWin application, we need a single NuGet package. It's system web. Here it is. NuGet looks up the system web package. We're using the OWin middleware here for the C# professionals in the room. And let's write the startup code. Really very simple startup code. First we need a using Microsoft.owin.extensions, and then we create the configuration function, public void configuration, and it gets an iApp builder interface. We need another using here. Let's call it app. And we will do the very simplest OWin solution that you can do. So we just say app.run, and we get a context, and on this context, we can say context.response.writeAsync hello world. Really the very, very simplest ASP.NET OWin solution that we could think of. Well, in fact, it's not ASP.NET, it's just OWin here. So the last one that we need to tell the system where to find the configuration. So let's create an assembly attribute here, OWin startup, add the using, type of, and it's called ASP.NET sample.startup. That's it. Let's try to compile this very, very simple application, but I'm sure you can imagine that in real world you would write a lot more code with some web APIs and views and things like that. In my case, I'm going to run it and it should say, wow, hello world. By now, we have not used Azure at all. The entire development was done locally. We could also access local database servers like LocalDB or an on-prem SQL server. But now we want to push our application into the cloud. We have already learned how to use FTP for that. I already showed you with a Node.js application how you can use Git to deploy your application, and this time we are going to use the full feature set of Visual Studio because Visual Studio is capable of communicating with Azure Web Apps directly. So we just have to right-click here and select Publish. Visual Studio knows Azure websites. I'm already signed in with my account, and I get a list of websites, and I see the ASP.NET website that I created a minute ago. Let's take this one. With my credentials, Visual Studio went to Azure and downloaded some deployment mechanisms, some deployment settings. The first one I would like to draw your attention to is the publish method. Visual Studio will use web deploy. That's the same web deploy that you might be familiar with from your on-premise IIS implementations. It's going to use web deploy to send our application into the cloud. That's a very handy feature because you can use the same publishing method, web deploy, for your on-prem IIS and your Azure Web Apps. Let's hit next. Next, we have to decide whether we want to push a release or a debug version. And in our case, I want to push a debug version because in the next step, I'm also going to show you how you can use remote debugging for your Azure Web App. So we will run the web app in Azure. We will use Visual Studio on-premise, We'll set a breakpoint, and hopefully the breakpoint will be hit although the application is running in the cloud. If we would have databases in our config file, we could rewrite database connection strings here. Imagine you want to test and develop your application locally, then your configs would point to local database servers. But these database servers are not available in the cloud. Of course they aren't. So therefore we have to do some rewriting, some settings, and this can be done during publish. Of course, you can again override the connection strings in the Azure portal in the configuration section. But you can do it, as you see it here, during publish. That's it. Next, we can do a preview. The preview would detect which files are already in the cloud. It would compare the files in the cloud with the changes that have been done locally and just deploy the changes. Well, in our case, there is nothing in the cloud yet. This is our initial publish, so therefore it makes no sense to preview that. I'm going to hit publish immediately. And for those of you in the room who are familiar with cloud services, for instance in Azure, a typical deployment takes minutes. You have seen how fast the deployments with Azure Web Apps is. It was a question of seconds. It was nearly instantly. Well, to be honest, once your application grows larger and larger, deployment takes a while because, well, of the bandwidth. It's simply a matter of bandwidth. But the beauty here is if you change a single file and you publish it from Visual Studio again, Visual Studio will only upload the changes, the single file. It will not upload the entire DLLs and things like that. So the publish, in many cases, is quite fast with Azure Web Apps. So it's running here in Azure Web App. This is exactly what I wanted to show you. But now I want to go one step further. Imagine in this application we might have a bug, as we have seen before. But in this case, we do not only want to use log streaming, but we really want to use the debugger. We can activate the debugger here in the settings area. I go to application settings. And I turn on remote debugging. I have to select the Visual Studio version that I'm going to use, in my case 2013, and I hit save. With that, Azure is configuring the application to enable remote debugging. It does all the necessary things to the network stack and things like that. Debugging should be now enabled, and we can go back to the Visual Studio instance. I can now hit a breakpoint or set a breakpoint here and run the application in Azure. How can I do that? Of course, it's not enough to hit F5 because F5 would run the application locally. We have to somehow connect Visual Studio with our Azure Web App and attach our debugger to the web app running in the cloud. And we do that in the Server Explorer on the left-hand side. I already registered my Azure subscription with Visual Studio here, so I can immediately look at my websites. And if everything works out right, we should see our, yes, here it is, ASP.NET application running in the cloud. I hit right mouse click and say Attach Debugger. I could use Attach Debugger for Node.js too, but this was the previous sample. Now we are in the C# world, so I just select Attach Debugger. It takes a few moments, and then our application is running in the cloud, and the breakpoint is hit. That's the important thing. My Visual Studio is running on-prem. I can still use things like watch points, watch expressions, all the things you are used to from local debugging, but the application is really running, as you see here, in the cloud in AzureWebsites.net. I could do some troubleshooting, I could do some bug fixing, and at the end I hit F5, let it run through, and here we see again our hello world. So even if you have a platform as a service offering and you give away a certain level of control, so you just use an existing platform, you can still use debugging and troubleshooting functionalities and techniques that you are used to from on-prem development. This was our third example where we used Visual Studio to directly deploy our very small OWIN application into the cloud. The next and final step will be connecting our Azure Web App with Visual Studio Online and set up a continuous deployment process to push our very simple web application via Visual Studio and build controller in the cloud into our web apps. For that, we go back to the portal and create our final Azure Web App. Let's do that together. Web App. Let's call it GAB-AT 2015, and this time call it VSO for Visual Studio Online. Again, I use the existing service plan and just hit create. This is going to take a few moments, and we can use the time to start Visual Studio Online and create a project there. Here we are in my Visual Studio Online account. It's called Rainer Demo TFS, as you can see here. And I cleaned up a bit here, so this demo TFS is entirely empty, so we can create a new project. Let's call it GAB 2015 VSO and use Git for deployment, for source control, for version control. Hit create project. It will not take long, just a few seconds, and we have a new Visual Studio Online project. I'm not going to go any deeper into application lifecycle management and requirements management and things like that. This is not the core focus of this presentation. We really want to focus on version control and on building in the cloud. Our new project is up and running, and now we have to connect our Azure Web App, which you see here, with our Visual Studio Online project that you see here. And currently, this is best done in manage.windowsazure.com, so the current production portal. There are some glitches in this area in the new portal, so we will stick to the old one for this process. Probably in the next few weeks or months, this will work in the new portal too. Let's see. Okay, here we have our web apps. Let's switch to the web apps view here. Go to our web app. Here it is. And down there you see integrate source control. We already used that a few minutes ago when we were setting up the connectivity to our local Git repository. This time we want to take it one step further and use Visual Studio Online. The system will ask us for the URI of our Visual Studio Online account, and as I told you, it's called Rainer Demo TFS. Authorize now. Now we get asked whether we are sure if we want to hook up our GAB-AT 2015 VSO web app with our Visual Studio Rainer Demo TFS account. We accept that. Next, we can choose a repository, a project where we want to deploy our stuff to, and in this case, I'm using the new project that we just created in Visual Studio Online. Yes, that's fine. And now we are linking the team project in Visual Studio Online with our Azure Web App. And whenever we build something in our Visual Studio Online build controller, we can use continuous integration and continuous deployment so that Visual Studio Build can export or publish our application if everything turns out right. So if everything can be compiled, if the unit tests are running successfully, then our application can be deployed to our web app. So let's try that together. We have web app connected to Visual Studio Online. Now we need some code. Okay, let's close the solution here. and connect our Visual Studio with our Visual Studio Online project. Select Team Project. You can see this is our new project, GAB 2015 VSO. Let's connect this one and double click on it. The system tells me that I have not cloned this repository locally. No problem, let's do that one. We will stay in our samples directory, but I will remove blanks here just to have a nicer path, and hit clone. That's it. We can go into Explorer. Here it is, and you see it's entirely empty. We have our .git directory, so we have a local Git repository, and this repository is connected to our Visual Studio Online repository. Okay, let's take the code that we have written a second ago. So I will maybe let's do the following. Let's take this solution file here, copy it into this folder, and let's take this code here. I'll just pick the CS project file, the config file, and these files, copy it, and go here. And finally, I have to change my solution file because it's now in the same folder. I have no subfolder anymore. And that should be it. Let's open the solution in Visual Studio and see what's happening. Okay, Solution Explorer. Here we have our startup file. Let's try to build the application. Oh, I forgot to copy the properties folder. No problem. Let's go here and copy the properties folder. Here it is. Let's show all files. Refresh it. Here's the properties folder, and here is the assembly info. Okay, that looks good. Let's try to build it again. Build was successful. Very good, very good. Let's try it locally. It should again say hello world. Yes, here it is, hello world, so it works locally. Now we can publish this into the cloud, but we should really change this a bit. So again, we need a git ignore file here to make sure that we only publish what we really need. So we can make a git ignore file, and we can safely ignore our bin directory, our object directory. We can ignore our packages directory, and we can ignore the CS proj file, and we cannot ignore the CS proj file because we need to publish that in Visual Studio Online. Yeah, that's it. For this simple example, that should be sufficient. Git ignore. Okay. Let's go to Visual Studio and publish our changes to Visual Studio Online. You see, we got lots of untracked files. Oh, we don't need the publishing profile here. I can ignore these files. The rest looks good. We can say add all and do an initial commit. Okay, we could commit it locally, but in my case, I want to commit and push our changes so that we really have everything not only in the local repository, but also in the cloud. Let's check it. I go to Visual Studio here, I go to Code, and here it is. You see, we have our code in the cloud. Wouldn't it be nice if Visual Studio Online would now pick up any change that we commit, run a build, check the build, and publish it to the Azure website? This is exactly what we are going to do now. So let's go back to Visual Studio and take a look at the builds section. Wow, you see, something happened. There is already a build triggered. Why? What happened? The magic is here. It's just like Harry Potter. It's just like magic, you know? It's not magic, in fact. It is a build definition. And this build definition was created because we connected our Visual Studio Online account in the cloud with our Azure Web App. This build definition was set to continuous integration. This is the default value set by the integration of Azure Web Apps and Visual Studio Online. And here we have some source settings. You see it's taken the master branch here, and it has some defaults. It uses the hosted build controller, and it even has a defined process. It is the Git continuous deployment template. It is a workflow foundation file that you could even download and configure, customize if you need to. In many cases, you will be fine with this one. You will be fine with the standard workflow, because the standard workflow, it compiles your solution, it runs all your unit tests, it checks if the compile was successful, if the unit tests are successful, and if everything is okay, it takes the build results and publishes it to the connected Azure Web App. That is essentially what this workflow does. Again, you can customize it, you can download it, and even if you customize it, you can still run your build in the cloud in the hosted build controller. Okay, this workflow was automatically triggered because we checked in some changes. Okay, so let's take a look at the build result. Oh, it failed, as you can see. I did something wrong, so let's see what we have here. Oh, it cannot find the OWIN, startup, and so on DLLs. Well, I think I screwed something up when copying the source code. Let's see. I have my packages.config. This one looks good. Now take a look at the references and take a look at this one, OWIN here, and I see. You see, we have the C samples packages directly here, but it should say something like C samples, and then it should say GAB 2015 VSO and then packages. The DLL should be looked up here. So we have something wrong. So let's remove the Microsoft OWIN here and the system web and the OWIN packages, and go to here, manage NuGet packages, and uninstall these packages and simply reinstall the system web. I'm sorry that I screwed this up when copying the source code from the first sample, but well, maybe sometimes you do the same mistake and then you can remember me doing stupid things. And let's see if it works now. OWIN and properties, let's check the path. Yes, this path looks perfectly fine. Let's check the packages.config file. Yes, it also looks perfectly fine. So we can go to Team Explorer and check in our changes. Here we are. We only changed the CS_proj file here, so this is included, and we can confirm it. Changed wrong path and commit and push. Yes. So now our changes were pushed into the Git repository, and if everything works out right, a new build should have been triggered. And here we are. Here is the build. Last time it took 74 seconds with the wait time of 44 seconds until our build is picked up by a build controller, so it will take a few moments. You know what? I will pause the recording until the build has finished, and I will write back as soon as I have the results for you. Welcome back from the short pause, and this time, once I corrected my stupid mistake, the build turned from red to green. You see, everything was fine. We can take a look at the log if we want, but we see it already in the summary. we have a deployment. The website was deployed to this site here, and we can try to launch it, and it should say, yes, it should say hello world. You see, if we take a look, for instance, at our website, here it is, with a VSO, you see the active deployment, and it was done through an individual continuous integration. The continuous integration run was triggered by checking in changes in Git. Git automatically triggered the build checked the build quality. In our case, there were no unit tests involved. It was just successfully building the application. And once this was successful, it took the results and deployed them to Azure websites. So with that, you have seen 4 different ways of deploying applications to Azure websites with various development technologies. The first one, let's go back here to recap. The first one was our static web example. Imagine you're just writing client-side code with Bootstrap and AngularJS and things like that. You can host such static web applications, and you could use a very simple deployment mechanism like FTP to roll out your applications. If you want to have something that is a bit more professional and you want to have version control involved and things like that, you can go for deploying your application using Git. I showed you how to use even server-side logic with JavaScript by creating a local Git repository and pushing your changes from the local Git repository out into the cloud by using your Azure Web App as a Git repository server. The next step was Visual Studio Online. We changed from JavaScript to C# and OWin or ASP.NET, just what you prefer. We used Visual Studio and the Visual Studio Azure integration to publish our code directly from within Visual Studio into our Azure Web App. I showed you how you can do some basic troubleshooting things, like for instance running remote debugging from your local Visual Studio with your Azure Web App in the cloud. And finally, the final sample was a really professional setup where you're using an ALM system in the cloud, namely Visual Studio Online, with continuous integration with a hosted build controller where we connected Visual Studio Online with Azure Web Apps, and we triggered building in the cloud and publishing of our ASP.NET application written in C#. With that, this session is over. I hope you enjoyed our short walkthrough, our scenarios with Node.js, C#, ASP.NET, and so on of Azure websites. I wish you a beautiful rest of the Global Azure Bootcamp. Send me questions via Twitter or take a look at my blog, which you can find on www.software-architects.com. We are writing a lot of stuff there, mainly software development on the Microsoft stack. I would love to hear from you. Wish you a nice Global Azure Bootcamp and see you next year. Goodbye.